let me try a different way of approaching how to determine if a salt is an acid salt, a base salt, or a neutral salt. The first thing you have to do is recognize a salt. A salt is an ionic compound. First of all, where the cation is not H plus and the anion is not OH minus or O2 minus. Why? Because then it would no longer be a salt. In the case of having a cation that's H plus, it would be an acid. And having an anion that is OH minus or O2 minus, over here, it would be a base. So this is the criteria for an acid. This is the criteria for a base. So it's not an acid or a base, it's a salt. But a salt can be acidic or it can be basic based upon its ions. So let's start with the cation. Let's focus on the cation. The cation can either be neutral or it can be acidic. Okay, so how are we going to know whether it's neutral or acidic? To be neutral, it needs to be a 1A or 2A metal. So let me give you an example of a 1A metal, Na+. Okay, let's think about why that would be neutral. Does it have an H plus on it that it can donate? No, it does not. Does it could it accept a proton, accept an H plus? Well, certainly not, because H pluses are positively charged, and an Na plus and an H plus would repel each other. So it doesn't have a proton to donate, and it certainly could not accept a proton either. So it is neutral. Now, when would a cation be acidic? There are two possibilities. It could be the conjugate acid of a weak base. So let's talk about that for just a minute. Weak bases are recognized because they have a nitrogen with 3 bonds. Okay? Those are your weak bases. So NH3 is an example that we know. Okay, that's a weak base. What would its conjugate acid be? The conjugate acid would be, take that weak base and add an H plus to it. That would give us a cation. That would be something like NH4 plus, for example. This is the conjugate acid of this weak base. So anytime you have the conjugate acid of a weak base, and I've shown you how to recognize it, then the cation is going to be acidic. So that is one way to be acidic. There is another, more obscure way to be acidic, and that is to be a small, highly charged cation. I don't want to say cation. Let me change that word to a small, highly charged, something like Fe3 plus. It still doesn't have a proton to donate, and it still cannot accept a proton, but what it does is it surrounds itself with water molecules when you dissolve it in water, and that attraction weakens this bond and allows it to donate the proton off the water that attaches to it. So that's kind of obscure, but it can happen. You can have an acidic solution even though it's not the conjugate acid of a weak base. Most of the ones that you run across that are acidic are going to fit this category. All right, so what did we say here? We said that a cation is either going to be neutral or it's going to be acidic, and we have learned how to recognize that, okay? How to recognize that. All right, let's go over to the anion. The anion can either be neutral or it could be basic. So let's see how we are neutral. An anion is going to be the conjugate base of a strong acid. If it is the conjugate base of a strong acid, it will be neutral. Here are some examples. Cl minus is the conjugate base of HCl, a strong acid. It is a neutral anion. NO3 minus is the conjugate base of HNO3. HNO3 is on my strong acid list, so this is neutral. We have very few strong acids, so we're going to have very few neutral anions. You have to memorize the strong acid list. When is it basic? When it is the conjugate base of a weak acid. So all the other anions out there are going to be basic. All right, so now we know whether or not an anion is neutral or basic. Okay, we have fewer things to qualify them than we had over here with the cations. All right, so now we can look at a salt, examine the cation, and know whether it's neutral or acidic. We can examine the anion and know whether it is neutral or basic. Okay, those are our choices. Now we have to talk about the salt and decide whether the salt is acidic or if the salt is basic. So what happens if a neutral cation gets together with a neutral anion? Well, we would have a neutral salt. What if the neutral cation got together with a basic anion? Well, we would have a basic salt. What if the cation is acidic and the anion is a neutral? Then we would have an acidic salt. And we have one last possibility. We could have an acidic cation getting together with a basic anion. And what I say here is we can't predict just by looking. We have what we call the battle of the Ks. The Ks, not Kas, but just the battle of the Ks. What do I mean by that? We would look at the Ka of the cation and compare it with the Kb of the anion, and whichever is bigger wins. So it defines the salt. So if the Ka were bigger, it would be an acidic salt. If the Kb were bigger, it would be a basic salt. So that's the battle of the Ks. So this is just a different way than that grid I gave you in our lecture to think about salts, and maybe it will be helpful for you.